Hello all. So today we are going to start a new chapter, that is structure of atom, and we have already covered 3 chapters till now in grade 9th, and that is first is matter around us pure, matter in our surroundings, and third one and the latest one is atoms and molecules, where we have understood this starting from the scratch what is matter, what it is made up of, uh, how does it exist in the nature, what all different forms of matter are there, and apart from that, how to distinguish between the pure matter and impure matter. And in the third one, we have understood what are atoms and molecules, and exactly when we talk about atoms and molecules, how do we write different atoms and molecules, what is valency, what are electrons, what are protons, what are neutrons. So we have got a basic idea in the last chapter about electrons, protons, and neutrons, atomic mass, atomic number, and then there was a theory which we have studied about, that is Dalton atomic theory. So there are few things which we have understood in the last class, or you can say in the last chapter, regarding the atoms and molecules. In fact, we have understood some points about the atoms, and now we are going to understand the atom structure in much more detail. And more than that, we are going to understand the subatomic particles, or the parts of your atom, which are electron, protons, and neutrons. So we have understood that atoms are very small particles. All the molecules are also made up of atoms. In fact, everything around us, me, you, this laptop, my pen, everything what you can see around us is made up of atoms. Atoms will have the same elements. Atom will have same shape, same color, same appearance, same number of electrons, same number of protons, neutrons, and the number of electrons, proton, neutrons will vary when you compare two different type of elements. And whatever is present around us is made up of different elements. It's not only one element's atoms which are constituting everything. Basically, everything is made up of different type of atoms, and that is the reason why they have different behavior, different appearance, different look and feel. So as we know, atoms are the smallest particles. I mean, when it was discovered long back, when the atom got discovered, everybody got so excited about it. When they got to know about that, there everything is made up of atoms, and hence everybody was so excited about it. They did a lot of different research on atoms to know how the structure of atom is, what it is made up of. And even before knowing what it is made up of, there were some scientists which have made their own claims regarding atoms, out of which one which is very known person, and who defined atom basically, and he had given us some points regarding the atoms, and that was Dalton. So we know, we had studied about Dalton atomic theory in the last class, and what was told by Dalton. So who was Dalton? Dalton was the one who could explain a lot of different characteristics of the atom, and he was the one who told that the single element is made up of same type of atoms, and two different elements are made up of two different type of atoms, and these atoms will vary in terms of color, in terms of sizes. So in these things, your different elements, atoms will vary. Shape will also vary. Shape, not exactly shape, we can say shape is spherical, but when we talk about shape, we are majorly talking about the size of the atom. So different materials or different elements are made up of different type of atoms, but when you talk about single element is made up of all same type of atoms with the same size, same color, same appearance. So, but along with that, Dalton told us one more important thing, the one which was very controversial, and that was atom is the smallest particle known, and atom is undivisible. Atom is undivisible. So this was his first statement regarding atom, which was taken by many people for a long time. But as I told you, when the atom got discovered, scientists got excited, and everybody in all parts of the world were trying to find out more and more about atoms. After some time, some scientists researched and got to know that atom is actually divisible. Or you can say atom is further made up of some substances. Atom was the smallest unit or smallest particle till then which was making all the matter around us, but they could actually break through the atom and they could understand that atom is also made up of something, and those somethings are called as subatomic particles of atom. Now we know about the atom that it is very, very small, cannot be seen through the naked eyes, and even through the electron microscope, it takes a lot amount of I mean, you can say you have to zoom it a lot to get to know the atom. Now you understand when we talk about subatomic particles, the subatomic particles which are basically making your atom would be furthermore small, and definitely forget about seeing through the naked eyes, even seeing through the electron microscope would be very, very difficult, right? So these subatomic particles are the particles which are the ones which constitute an atom and are very, 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 very small particles. So what are these three particles? There are three subatomic particles majorly. By the way, let me tell you, these are not the only ones. These particles have been further divided, and or you can say these particles have been further figured out at what they are made up of. Okay, but as per now, we will understand the basic three subatomic particles, and these are electrons, protons, and neutrons. What are these particles made up of? That is also scientists know now, but that you don't have to get deeper into. We just need to understand what is atom made up of. An atom is made up of three subatomic particles, that is electron, protons, and neutrons. Though we have spoken about these particles before in the last chapter. And we also understood one thing, that these particles are not just the neutral particles but have some charges on them. Some are charged and some are not charged. For example, if I talk about electrons, electrons are the particles which are negatively charged. All of us know the charges are negative and positive. We all know about it. The charges can be of two types. One is negative, one is positive. So electrons are negative, protons are positive, and neutrons are the ones which are neutral. They don't have any charge. Okay. Now for your information, electrons are the particles or subatomic particles which have very, very, very less mass as compared to protons and neutrons. Very, very less mass. You can say approximately 1700 times lesser than a proton and a neutron. We will talk about it in detail. But electrons are the particles which are very, very light, or you can say have negligible mass. So electrons are the ones which have negligible mass. But when you talk about protons and neutrons, they carry the good amount of mass, or you can say are approximately 1800 times more than the electrons. And that is the reason when we calculate the atomic mass, we ignore electrons' mass and we just consider protons' mass and the neutrons' mass. And if you remember, in the last chapter, we have done mass number is equal to what? Or atomic mass is equal to what? Number of protons plus number of neutrons. So we are not even talking about electrons over here. We're not even considering electrons. Why? Because electrons are very, very, very light and have negligible mass and hence do not contribute much in the atomic mass. Okay, though we will be talking about everything in detail, but this is majorly our chapter is based on. So protons and neutrons. Now let's talk about the positioning of protons, neutrons, and electrons. So let's see how the positioning looks like. When we are talking about atom, just look at it, this structure, or you can say this diagram. Here in the center, you can see there are some positively charged particles being shown, and then there are some blue circles which have no charge on them. So let me take a different color pen. So this green ones you can see are some one type of particle which are green in color, and then you can see the blue ones overlapping or present inside, and these blue ones have no charge on them. And this whole dense area, is called nucleus. So this dense area is nucleus, nucleus. And in nucleus, we can find two types of particles present in it. One is protons and other is neutrons. Uh, by the way, every time when I'll be mentioning protons, neutrons, and electrons, I will not be writing protons completely, but I'll be just writing P plus, and I hope you will understand. P represents proton, and plus charge is a charge on it. Neutrons I'll be writing as N. So these protons and neutrons are present in the nucleus, inside the nucleus, which is a dense part of your atom. And then your negatively charged particles, which are electrons, revolve around that nucleus. Same way how you have sun in the center of the solar system and then planets revolve around. So similar kind of structure was discovered, or you can say was proposed by the scientists when the discovery of atom was happened. Or you can say when the structure of atom was discovered, this was the first structure, or this is how the structure of atom was explained. So electrons are outside in the free space revolving around the nucleus, and nucleus is the center dense part of an atom where neutron and proton is present. So we can also say when we talk about nucleus, nucleus is positively charged zone because neutrons don't have any charge, whereas outside the atom you have electrons present which are negatively charged. So electrons are outside, protons and neutrons are present inside the atom. So now we got to know that there are three subatomic particles. Electron is lightest, proton, neutron have almost the same weight and are almost 1800 times heavier than your electron, and that is the reason why we use protons and neutrons to calculate the atomic mass and we neglect electrons mass. When we talk about the positioning of electrons, protons and neutrons, electrons exist in the outer area of your atom. Neutrons and protons stay inside the atom, the dense area of the atom, which is called as nucleus, and nucleus is your positively charged area. Outside your nucleus is all negative charge. So that's how initially it was told that how atoms look like, and this is how we represent an atom in a simpler manner. Now, if you actually want to see how atom looks like or what is the actual structure of atom, let me show you. This is how we feel that atoms looks like now. So earlier, whatever was the discovery of the structure of an atom, that has been modified now, and now the new structure which has been proposed by the scientist is like this. So now you can see this is the center area. I'm not very sure whether it's visible or not. Let me just draw it with a different color. So this center area is shown over here, and you can see the protons and neutrons present in that center area. This is red color one balls are protons, and the green color balls are neutrons, and these are present in the dense area, which is called as I mentioned, this is called as nucleus. Okay, now when you talk about electrons, electrons don't have orbits just like the spherical orbits, but you can see the orbits are where the electrons revolve around the nucleus are quite different, and they have been arranged in a specific manner, and these are called as orbits where the electrons revolve around. They have a specific path, and that path has specific energy. The same way how Earth revolves on its orbit, Mars revolves on its own orbit, and it doesn't move out and move to some other planet's orbit. Exactly same way electrons revolve in their own specific orbits, and every particular orbit or shell, which we can say, has a limited capacity of containing electrons. So you can see we have marked few things over here, though it is a little complicated to understand. So this blue color ring, if you can see this blue color ring, this one, this, I'm not very sure whether it is visible to you guys or not, but this blue color ring, I need a darker pen. So this, the pink color where I'm showing this blue color thick ring is a K shell. It's the name of the shell. So K shell, which has maximum capacity to carry only 2 electrons. Then comes your L shell or L orbit, you can say, which is just next to it. So this is a 3-dimensional picture. If I have to show a 2-dimensional picture, that's how it will look like. So let's say this is my nucleus where where neutrons and protons are residing. And then let me draw some other shells. So this is, let's say, first shell. This my drawing is bad, okay, so please ignore. And obviously this doesn't look like this. I mean, they are equidistant everywhere. So this is my third shell. So this is a two-dimensional picture, and what I'm showing you over here is a three-dimensional picture. Okay, so this shell, the first shell, will be called as uh, K shell. It's just name of the shell. The another shell will be called as L shell. The third shell will be called as M shell, and so on. The first shell will have the capacity to carry only 2 electrons. L shell has capacity of carrying 8 electrons at a time. And all these 8 electrons will revolve around the nucleus here itself. 1, 2, 3, 4, 5, 6, 7, and 8. And so on. So we'll be learning this in this chapter. Going forward, first we will understand what are electron, protons, and neutrons, how the discovery was made, and then we'll get into depth of this as well. Okay, so this is how one structure of atom is, but let me tell you one more thing. The shell name doesn't stop at KLM, NOP, whatever. It is further. How the electrons have been distributed in each shell is called as electronic configuration. Electronic configuration. Electronic configuration is nothing else but just a way to represent how electrons have been divided in each shell. So when we are in grade 9th, we understand in terms of K, L, M, N, and so on shells. That means 2 electrons will reside in K, 8 will reside in L, and so on. That is what we will understand. And when we'll go to the higher grades, we will learn a further, you can say, further explanation, or you can say further in-depth knowledge of what exactly these KLM are made up of, and that is called as SPDF shells. So we will be, or SPDF subshells, my bad. SP, let me just write it a little more nicely. So SPDF subshells. Basically, in 9th, we are understanding each shell contains how many electrons and how to divide electrons when we are talking about a particular element. When we'll go to higher grades, we will understand in those shells also what are different compartments where the electrons live or electrons stay, and each compartment can contain how many electrons. So further in-depth idea of atom is what we are going to get in grade 11th, not in grade 9th. Okay, so our division of atom doesn't stop at KLM and shell, but also will go deeper in SPDF going forward. So this is about how the atom look like, or how the nucleus has electrons and protons, and how electrons are actually residing. They are not, the structure is not 2D structure like this. These are not just spherical, direct, back to back sphere or spherical orbits, but these are like this, the way how it is shown in this diagram. So this is how the scientists have given an idea that how atoms look like and how is the internal built-up of an atom. In this chapter, now we will understand in-depth knowledge of electron, proton, and neutron. Before that, now we know that we have substances inside the atom which are charged, like electrons and protons. Electrons have negative charge, protons have positive charge. How can we see their presence in day-to-day life? Obviously, we cannot see electron protons through the naked eyes, but how can we feel their presence? How do we know that the particles can be charged and particles are charged? So there are some examples in day-to-day life which you can perform, and you can say or you can see or you can feel that there is some charge, and because of that charge the things are happening around. At least all of us guys know that opposite charges attract each other. So if anything is negatively charged, will attract the positive thing, and the positively charged thing will attract the negative thing. So there are substances around us, there is matter around us which is charged and which have charged particles, and we can feel its presence by doing some small experiments at home. So let's see those experiments now. So as I mentioned that we will be understanding how the particles can be charged in the matter, or how to feel the presence of that charge in the matter. As I mentioned, each atom contains negatively charged particles and positively charged particles, but that is what scientists have told you. How will you realize it? How will you feel that yes, there can be some charge inside the matter, and how to feel the presence of that charge? So there is first example of it, and that is if we rub the comb in the dry hair, what we will find is that the comb will attract the small pieces of paper. Now, how this proves that there is some charge in the matter? Let me explain you. So, just let's see this diagram, or let me just draw a few things over here and then probably I'll show you the diagram. So, what exactly happens is when you have like hair, okay, hair strands, and then you comb it. This is the comb. Okay, my drawing is very poor, so please ignore that bad drawing. And our hair strands as well as comb, everything, in fact all the matter are made up of atoms. Okay, I have already mentioned that. So let me just draw it in a little more expanded version. Let's say this is just one single strand. I'm just spoiling the strand, by the way. Okay, let's say this is one single strand. Okay, this is a zoomed picture of a strand, and in that strand there is an atom. In fact, there are a lot of atoms which have combined to make this hair strand. As well as when you talk about the comb also has atoms inside it. So let me just draw the atom with a different color here. So this is the atom of your, the center part is nucleus and the outer are the other shells of atom. So what happens is when you rub, or when you comb your hair, dry hair through that comb, what exactly happens is due to friction or due to rubbing of hair and comb, the electrons which are present on the hair, basically on the in the atoms of the hair. So this is my this is the nucleus, this is the atom, these are the atoms of my comb. Okay, or rather than drawing the atoms, I can just simply mention these using electrons and protons. So number of electrons and protons will remain same because this doesn't have any charge right now. All of us know that the uncharged particles or a neutral atom will have same number of electrons and same number of protons. So initially when I'm talking about the hair as well as comb, hair has its own atoms, comb has its own atoms, and it will have equal number of protons and neutrons both ways, even in the comb as well as in on the hair. So assume that there each atom has some protons and neutrons, and I'm just showing them like this. So I'm just drawing it as electron, proton, electron, proton. I'm just randomly drawing. Please do not consider it as the actual number. So let's say your hair strand has so many electrons, 3 electrons and 3 protons. Just assume. It is just a simple assumption and simplified number so that you don't get confused. And your comb has, assume, uh, proton, electron, proton, electron, proton. So basically 5 electrons and 5 protons. This is very random number. Please do not consider it. Please do not. Okay, this is not the actual number at all. There are millions of atoms present in comb, millions of atoms present in one single strand of hair. So obviously it cannot, the number of electrons and protons cannot be so less. This is just to make the calculation simple. So when we rub the hair with the comb, or you can say when we'll comb our hair and the friction will produce between the hair and the comb, some of the electrons from the outermost shell or from the outer area of your atom of hair will jump and go and stick on the comb. So what will happen? Now comb will have its own electrons which were earlier there and some of the electrons of hair. So it's like the electrons of hair have jumped on the comb, and hence the total number of electrons are now different from what was there originally. So as I mentioned, there are 3 electrons in the strand of the hair, 3 electrons and 3 protons, and here we have 5 electrons and 5 protons. Now when we rub our hair with the comb, electrons will jump, will attach on the comb, and now the new number of electrons on the comb. So assume these 3 electrons have jumped on the comb. So now new number of electrons are approximately 8 and protons are still 5. So what can we say? That now number of electrons on comb are more than the number of electrons earlier, or you can say number of protons present over there. So now because Earlier, my comb was neutral because it has same number of electrons and protons, but now the number of electrons are more. And hence, my comb will be negatively charged. Negative I've just mentioned with a minus, okay? Negatively charged, or you can say it will have excess of negative charge on itself. The comb will have excess of negative charge on itself. Whereas when you talk about the hair strand will have just a positive charge because electrons it has given to the comb. Okay, so now what we have inferred from this from this experiment, or you can say from this demonstration, that when you are combing your hair, electrons of your hair are jumping on the comb, and now the comb has more number of electrons, making it negatively charged, or it has higher number of electrons, which is making your comb charged. So your comb has become charged by gaining the electrons of the hair. Okay, so this is about gaining the electron by comb and becoming charged, and that's how matter becomes charged. Okay, this is something which you can feel. How can you feel? If you take the comb and you take the pieces of paper just like that, they will not attract each other, but the moment you will rub it on your hair and then you'll bring it closer to the pieces of paper, why it will attract, it will start attracting. That means there is definitely some change which has happened inside the comb, which is making those pieces of paper to attract towards it. And what is the change in that? That earlier your comb had no charge on itself because it has same number of electrons and protons, but now the number of electrons and protons have changed. Number of electrons are more and number of protons are less. So your comb has got the negative charge on itself. This is the change which has happened on the comb. But why it is attracting the pieces of paper, that is yet to understand. So let's understand why now this charged comb is attracting the pieces of paper. So now look at this diagram which I have shown over here, and that will explain you how your comb is attracting the pieces of paper. For this you have to really take your own sweet time to understand, but try to understand, try to think logically. Okay, now when I'm talking about a piece of paper is again made up of atoms, and again atoms will have same number of electrons and protons, and that is why it is not charged, it is neutral. So same number of electrons and protons are present throughout on the piece of a paper. I have shown piece of the paper over here. This is my piece of the paper. Okay, so it has same number of electrons, protons. So let's say this is my piece of paper. So electrons, protons, or let's not write it this way. Uh, this is my atom, this is my atom, this is my atom, 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 atom. And I'm just showing that this is a nucleus in the center which will have some protons. Okay, so basically, as I mentioned, that now we have in the piece of paper, it is made up of atoms which will have fixed number of electrons and protons. I have taken a very random number over here. Random number, please do not consider it as a right number, because atoms, there are different type of atoms inside the piece of paper, and it's a very complicated structure. What I have taken over here is protons as 12 and electrons as 12 in each atom of the paper, which is a very random number. This has nothing to do with the paper. This is actually the number of protons and electrons of magnesium. I've just randomly taken to make the calculation simple and to make you understand it has nothing to do with the paper. So I've just randomly taken a random number that assume the atoms of paper have 12 protons inside the nucleus and 12 electrons outside. This is very, very random. Please do not consider it as the actual atom of piece of paper. Okay, this is just for your explanation. So I have just written over here in each nucleus you will have 12 protons, and outside I have mentioned 12 electrons, 12 electrons, 12 electrons, 12 electrons, 12 electrons. That means each atom will have 12 electrons outside. Now what will happen? Let's see. Let's say um, this is your atom, okay, which has a positive charge inside and negative charge distributed outside. This is the piece of paper's atom I'm talking about. So that would be the structure of the atom, or that would be the appearance of the atom, of a neutral atom of a piece of a paper. Okay, now what will happen when I'll bring a charged comb closer to it? So the surface of the charge cone has a lot of negative charges on it, or you can say it is negatively charged because the charge it has gained through the hair pieces. So when it will come closer, to this atom, what exactly is going to happen? Change in shape, change in shape or arrangement of electrons and protons. E minus is electrons and P plus is protons. That is what is going to happen when this charged cone will come closer to the atoms of the piece of paper, the neutral atoms of piece of paper. And how it will happen? Let me explain you. So assume this is my cone and this is the piece of paper. Just assume when it will come closer, the outer area of your atoms of your piece of paper will have electrons, and this is also negatively charged. What do you think that negative charge will repel each other, and that negative charge will try to go away from the surface of the cone, or the surface which is closer, it will try to go away from it. So this is my surface of paper which is coming closer to the comb surface. Comb is negative, and right now you have negative here, positive in the center, negative here, positive in the center, negative here, positive in the center, negative here, and positive in the center. That's how your actual arrangement is. When this negatively charged comb will come closer to it, this thing is going to change. So atoms of your piece of paper are going to change. And how it is going to change, let me show you. So this will not remain like this. These will change their shape in this way. Shape, or you can say arrangement, that negative charge will go away from the surface of the comb, or you can say the surface of comb which is closer to the piece of paper, or the surface of the piece of the paper, this negative charge will go away from it to avoid the repulsion, and the plus charge will get accumulated in this area. So basically the things which were equidistributed, basically outside there was electron and the inside area was your plus charge, that will get little distorted. Now the positive charge will come, or you can say nucleus will come in one corner, and the negative charge will get accumulated in the another corner. So that will become like this. If you guys can see over here, this will become like this. So negative charge has got in one corner and positive charge in the another corner. So that's how the arrangement will become. All positive charge will come and get accumulated in one area which is closer to the negative charge of the comb, or the surface of the comb. And the negative charge will go away from the surface of the comb so that it can avoid the repulsion. And generation, or you can say the rearrangement of negative and positive charges like this, or protons and electrons like this, is called the formation of dipole. What is dipole? If you just understand the literal meaning of dipole also, di means two and pole means generation of two poles which are opposite to each other. So basically the atom which was overall neutral throughout can also distort itself to accumulate all the negative charge in one area and positive charge in the another area and distort its shape a bit, and that will be called as dipole. Okay, so here this has got generated, this dipole has got generated over here. If you can see, I hope you can see why I have written the polarized molecule. I mean, if you see the way how we have mentioned it, this dipole, which I am telling you, this is dipole, and the generation or the rearrangement of electron and proton in this manner is called the formation of dipole. It is also called as the formation of dipole is also called as polarization of molecule or atom. Now, what do I mean by polarization? Polarization, again, literal meaning of polarization means creation of two different poles in a molecule. That means negative charge has got accumulated at one place and positive charge has got accumulated at another place. That's all. Do not try to complicate the definition. Polarization is nothing else but separation of two charges in two different areas in the same molecule is called polarization, and that is what exactly has happened over here. It is neutral, it is still neutral because total number of electrons and protons have not changed, but the negative charge has got accumulated in one area and positive charge has got accumulated in one area. Positive charge is on that surface, or positive charge has got accumulated on that surface, if you see, is on that surface which is closer to the negative charge of the comb. Whereas the negative charge has got away from there and it is far away from the area where the negative charge of comb is. So for that moment, till the time comb is closer to the pieces of paper, positive ends of the atoms or molecules of piece of paper will come closer to the comb, and because these charges are opposite to each other, positive charge and the negative charge of the positive charge of the piece of the paper and negative charges of the comb are opposite to each other, and hence they will attract each other. Are you getting my point, what I'm trying to explain you over here? See, it is not a permanent change on the molecules of the paper. It is just for that moment when the negatively charged comb came closer, the negative charges of the atoms and molecules of paper ran away to avoid the repulsion, whereas positive charge came closer to the comb so that they can have that attraction. The moment you will take that comb away from the pieces of paper, they will rearrange, they will again rearrange themselves in the same manner how they were earlier. So basically positive charge in the center and negative charge distributed throughout in the atom outside. So that change which I am telling you, the shape change, or you can say arrangement of electron proton change, is momentary till the time the charged comb is coming closer to that piece of paper. And because positive charge has come closer to the surface of the comb and negative charge has ran away to avoid the repulsion, there will be attraction between the piece of paper and the comb. This kind of attraction is called attraction between charged comb and neutral but polarized piece of paper is called electrostatic force of attraction. Electrostatic force of attraction. Electrostatic force of attraction is the attraction between the charged particles. So one is the properly charged comb and another is not charged but has got dipoles in it, because of which charges have got separated. Negative charge has got accumulated at one place and positive charge has got accumulated in another place. Basically it has become polarized, and when these things attract each other due to the opposite charges, the force of attraction which comes into the picture is called as electrostatic force of attraction. So here, why we have written a term induced charge over here? Because induced means forcefully generated. It was not a charge. The piece of paper is not charged. It has got generated because a charged object has gone closer to that piece of paper and had forcefully made atoms or molecules, negative and positive charges or electrons, protons, to rearrange themselves in such a way that negative can avoid repulsion and positive can get attracted. So induced means forcefully generated dipoles, or you can say due to the presence of a charged particle or due to the presence of something, when the nature or behavior of a substance changes, then it is called induced. Because as soon as you will remove that comb, as I mentioned, the atoms or molecules, negative and positive charges or protons and electrons will rearrange themselves in their original way. So that got induced or generated just because of the presence of charged comb. Okay, now let me show you a GIF over here which will show you exactly how the piece of paper gets attracted. So look at the GIF over here. So you can see the GIF over here, the pieces of paper are getting attracted towards the charged comb. I have already told you the comb has negative charge and the dipoles got generated into neutral bits and pieces of the paper. And this is our first example which we can experience in our day-to-day life, that the matter can be charged and matter does get charged by multiple activities, and we can observe it. Though we will not be able to see the electrons and protons and negative charge and the positive charge, but we can definitely feel change in the material due to different actions we have performed on it. Let's talk about the next example. So next example is very similar to what we have done just now. So now here what we are taking is, we are taking a glass rod, and then we are taking a piece of silk cloth. So silk is what we are taking, and the glass rod we have taken, and we are rubbing glass rod with that silk cloth. You can see it over here in this picture. So I have taken the glass rod over here and the silk cloth, and then what is happening when we are doing this, when we are rubbing this, the electrons of glass rod, electrons of glass rod get transferred to silk. So basically silk atoms and glass rod atoms were neutral earlier. Now glass rod has given some of its electrons to the silk. Silk has become negatively charged. Silk has become negatively charged, so it would have generated the negative charge on itself. It would have generated a negative charge on itself by gaining extra electron from the glass rod, whereas the glass rod would have generated the positive charge on itself because of the rubbing done by silk cloth. So now what we can say, earlier assume there were 6 electrons and 6 protons in the or on the glass rod. Again, this is very random and stupid number, okay, so do not consider it. And assume 10 electrons and 10 protons on the silk cloth. When we will do the rubbing, glass rod will give its electrons to silk, and the new number of electrons are, let's say, 3 electrons and 6 protons. So 3 electrons have been transferred from glass rod to silk cloth, and now the number, this is about glass rod. And when I talk about silk cloth has 13 electrons and 10 protons. This is silk cloth. So overall charge on glass rod, what do you expect? It is 3 electrons, 6 protons. So minus 3 plus 6. So total charge is plus 3. So that means your glass rod would be positively charged. Whereas when we talk about silk cloth has 13 electrons and 10 protons. That means it will be having 3 negative charges, or you can say it will be a negatively charged substance. This concept we have learned in much more detail in the previous example, so I'm not getting into depth of it, but I hope you understand. The silk cloth has become negatively charged, whereas your glass rod has become positively charged by rubbing and by transferring electrons from glass rod to silk cloth. Now we have got the glass rod which is charged now, which is positively charged now. Now when you will bring it to the inflated balloon, bring it closer to the inflated balloon, what will happen? Same thing will happen which happened to the molecules of piece of paper. So basically this glass rod is positively charged, and the particles of balloon would be earlier quite symmetric by shape and by division of negative and positive charge, because positive charge would be in the center and negative charge would be throughout in the atom outside. But as soon as the positively charged glass rod will come closer to it, the shape will get distorted. This is how the shape will be. All the negative charge will get accumulated at one area, and positive charge will go away from the surface of the glass rod, will go away from the surface of the glass rod. So basically the structure which was like this earlier now has become like this. So the molecules which were atoms which are looking like this now have become negative charge at one area and positive at one, and this negative area or negative part of your distorted atom or molecule will get attracted towards this positively charged glass rod, whereas this positive charge will keep itself away from the surface. Now there can be a question from many people that why this positive is not repelling that positive of glass rod, because it is away from the surface, and that is the reason why dipole has got generated, because positive charge didn't want it to get repelled. It stayed away in that molecule and atom and pushed the electrons towards the positive charge. so that there can be attraction between positive and negative, and positive part of that molecule or atom can stay away and far away to avoid the repulsions from the glass rod. That is why there will be no repulsion but attraction between the negative charge got generated or negative end which got generated in the balloons, atoms and molecules, and the positive part or the positive charge of the glass rod. This is again the force of attraction which will work here will be called as electrostatic force of attraction, and this also gives you a very fair idea of how charges gets generated on the substances or on the matter, and this can be experienced, seen, and we can understand that matter is actually charged and it has charged particles like negative and positive. So now we have got enough data, enough details about negative charges and positive charges, but we have to now understand how these negative particles or negatively charged particles or positively charged particles got discovered. How did we actually figure out that these are negative or these are positive? What was the experiment taken place, and how did we come to the conclusion that this is electron, this is proton, it has lesser mass, proton has higher mass? So how did we gather all this information? That we have to learn in the discovery of electrons, protons and neutrons. That is the next part of this chapter.